All right, this is the, what is this, 2026? Unit 5 test. I figured I'd walk you through stuff. If you couldn't figure it out on your own or you need the details, here you go. I'm going to make, I think, 5 different videos, one for each page. All right, so the first 2 pages were evaluating integrals. Hopefully you saw the integral of 1/5 x to the 4th dx, and that's got to be some version of x to the 5th plus c. And there were plenty of people who missed the coefficient. If I took the derivative of x to the 5th, I would get 5x to the 4th, so that means I want 1 over the 5 I already had times another 5, or 1 over 25. Another thing people did poorly that chose to check, they had bad notation. There was at least one person who did like derivative of this and got 1/5 x to the 4th. And while I know what you're talking about, you didn't say you were doing the derivative. This kind of says, hey, everything is all the same. We don't want to do that. So if you're going to check, love the idea, actually check off to the side, good notation, the derivative of 1/25 x to the 5th plus c is going to be 5/25 x to the 4th, or 1/5 x to the 4th. That's how you would check if you wanted to. Always have good notation. I guess it doesn't matter whether you go left to right or top to bottom. This was meant to see, hey, can you do 2 relatively straightforward things at the same time? Most of you could. You see 2 over x, that's just 2 natural log of the absolute value of x. Not the worst thing if you forgot absolute value, but plenty of people did. Antiderivative of x is x squared, and chain rule would be multiplying by 2, so we would have to divide by a second 2. Or let's see, what's another way to say that? You could think of this as 1/2 already, and then x squared over 2, which is why you get the 1/4 x to the 4th. All right. Now this one, some people made it hard, and it's fine, but super annoyed I had to check by multiplying everything out. This was meant to be U substitution. Where the heck is it? Well, I don't have the paper right in front of me, but I remember it was like 288 x to the 9th over 7, something like that. I don't know. There was some crazy version when everything was multiplied out. But I see this as, and you don't have to write out the U substitution, but if you do partial U substitution work, you like do the whole thing. There was even one person who did U substitution but didn't say what U is. It just magically transformed into U's, which is super confusing. Okay, so du is 12x squared dx. And, you know, it all depends how you want to do it. I see that 18 as a, well, I'll show you, 3 outside. Oh, wait, how do we want to do that? Yeah, 3 times 6, x squared. 4x cubed plus 3 squared dx. And all I need to do is multiply in an extra 2, because now that 2 times 6 is my 12, and I'll put a 3/2 out front. Or at least I'll put the 2 out front to make that 3/2. So my new integral is going to be 3/2 of 12x squared dx becomes du, u cubed, and 3/2 of, what is it? 4x cubed plus 3 squared. Oh, nope. 4x cubed plus 3 cubed over 3 plus c. And so we could just say 1/2 of 4x cubed plus 3 cubed. Of course, plus c. Over here, this is the one that, let's say, plenty of people kind of knew what to do. It was apparent. And, you know, another thing is you just may want to look up a formula. I don't do it the formula way, but most people realize this was not U substitution. You might have a chance at U substitution if there was an x in the numerator, but this is the antiderivative is going to be inverse tangent. So I'll rewrite this 2, so that way I have a 1 over. I guess you can do U substitution by the time we get there, but your call there. So if we factor a 36 out, because we want 1 plus stuff squared in the denominator, so we have to factor out that 36. And so you get 5 over 6 here. Maybe we do that in 2 stages. So we'll do 1 plus 25x squared over 36. And then maybe change that to 1 over 18. Right, the 2 over 36. So 1 over 1 plus, and we want this form 1 over stuff squared, or 1 plus stuff squared, which is 5x over 6. So I'm going to have 1/18 inverse tangent of 5x over 6, and I'll just multiply by 6/5 out front, the reciprocal to undo, counteract, take account for the chain rule. And then 6 over 18 is 1/3, so 1/15 inverse tangent or arctangent of 5x over 6 plus c. Let's see. And then, you know, when I was putting this in, it was another one that was supposed to be easy or supposed to be straightforward. But for some reason, people get confused on the negative exponent. So it's still just power rule. And we're going to add 1 to the exponent. And then I guess what I'm thinking ahead is -2 times this thing has to be equal to my 4 as the coefficient. So that's got to be another -2. Likewise, this is going to be x to the -1, because you add 1 to that exponent -2. And then what do I multiply times -1 to get -3? That's, of course, 3 plus c. You can leave it like this, or -2 over x squared plus 3 over x plus c. Those are all good. Okay, just one more on this page. So you could definitely do U substitution. You could definitely multiply things out. You could think through it. I don't know which way you want to go. I think most people actually just decided to multiply everything out. So 16x squared plus 8x plus 1, all dx, gives us 16x cubed over 3 plus, what is that going to be? 4x squared has the derivative of 8x plus x plus c. If you did, what other could we do? Just in case to give you options for the future. You should know this is going to be something cubed over 3 plus c. And what would that be? Well, it would be 4x plus 1 cubed. And so you could just divide by a 4. So you could also have 4x plus 1 all cubed over 12 plus c. Those are two good ones. I'm not really sure what else you folks did. Hope that helps.